So I've been asked this question many times. If you can still get sick from the disease that you've been vaccinated against, then why get vaccinated? It's a very good question, and one that the answer involves some anatomy, some pathology, and some immunobiology to fully understand the answer. But I'm going to try and keep it fairly simple today. The simple answer is that the length of disease symptoms directly correlates to the severity of the disease. Let me put this in another way. If the pathogen is in your system for a shorter period of time, this minimizes the chances of severe illness and severe consequences from that pathogen. The longer that the pathogen remains in your system, the more at risk you are of having the seriousness of that pathogen's ability in your system. When a pathogen, and let's say the bacteria Bordetella Pertussis, which causes whooping cough, somehow makes its way into your nose, mouth, or is breathed into your respiratory tract. So what happens next? Well, what happens is pretty much the same if you're either vaccinated or unvaccinated. And that is, your body makes a defense against this foreign body or this foreign disease or pathogen. That's sort of where the similarities start and end between vaccinated and unvaccinated people. What happens immunobiologically, while somewhat similar, is vastly different between vaccinated and unvaccinated people. In your body, you have certain places where pathogens can be detected within specialized cell patches, such as in your tonsils. I'm going to ignore these for now, and we're going to assume that the Bordetella bacteria has bypassed your tonsils and may have been breathed in somehow. So what happens next? Well, what happens next is kind of fascinating. It just is amazing. In both vaccinated and unvaccinated people, special immune cells called phagocytes are always on the lookout for anything that you breathe in that you shouldn't have, such as dust or dust mites or pollen or other rubbish or good old Bordetella pertussis. These phagocytic cells, they're immune cells with names like monocyte, and monocytes can differentiate into macrophages and dendritic cells. We also have neutrophils and mast cells. So these phagocytic cells find, engulf, and represent a part of the pathogen for T and B cells to respond to that pathogen and remove them. This whole process from phagocytic cells finding, ingesting, and presenting an epitope, which is an external fragment of the pathogen, to T or B cells, is where the major difference lies between vaccinated and unvaccinated people. You see, the very first time your body's immune cells see and recognize a pathogen or a part of a pathogen, they may be in a vaccine or in a wild-type virus. If your body has seen the pathogen before, then T and B cells can be on the scene almost immediately, and they remove the pathogen. If your body has not seen the pathogen before, then phagocytic cells need to find, engulf the pathogen, present some of that epitope, and travel to the lymph nodes to present their findings to T and B cells. T and B cells then need to differentiate to be capable of neutralizing the pathogen. The difference here is time. The time difference between vaccinated and unvaccinated people is astounding. Your body mounts a defense using what are so-called immunoglobulins, or Ig somethings, which is also called antibodies, and these are structures produced by immune cells, which they recognize pathogens, and they recognize like receptors on cancer cells or specific sugars on bacterial or viral cell surfaces. They recognize hormones, chemical compounds, or nucleic acid structures in DNA. Immunoglobulins are named IgA, IgD, IgG, IgE, and IgM. The two main immunoglobulins in action at the time of pathogenic disease is IgM and IgG. I'll come back to IgM and IgG. But in the case of Bordetella Pertussis, which is a small gram-negative coccobacillus that infects the mucosal layers of the human respiratory tract. All it has to do is be able to get into the mucosal layers of your respiratory tract, and then it can start reproducing and destroying cells, causing sickness, illness, and stuff. Bordetella pertussis is a nasty disease. The cough can be so violent that people with pertussis can crack ribs. They can break blood vessels or develop hernias. Pneumonia or seizures can also develop. Your infants can also experience bouts of apnea in which they briefly stop breathing while they're sleeping. What has cracked ribs, pneumonia and apnea got to do with vaccinated versus unvaccinated immune response? Well, quite simply, the longer the bacteria has in your body, the longer it takes to clear the pathogen and the worse the symptoms may be, up to and including death. Unvaccinated people have an initial immune response led by IgM. An IgM response in both vaccinated and unvaccinated people is similar. The initial IgM recognition phase takes about 7 days to fully activate in an unvaccinated person. While this IgM also activates IgG response to start to clear the pathogen takes about 20 to 45 days to fully be productive in an unvaccinated person. In contrast to this, when a pathogen is introduced to a vaccinated person, whilst the IgM response still takes about 5 days to be in full effect, and the IgG response is absolutely massive, and it responds within 7 to 10 days, full effect. There's a massive difference between a pathogen clearing process in full effect after 7 to 10 days and a pathogen clearing process of 20 to 45 days. The extra 10 to 35 days difference makes a huge difference between the severity of the disease and the repercussions from that particular disease and pathogen. Generally, whooping cough is it's less severe and only lasts around 10 days. It's a much better outcome for your loved one than a more severe reaction version that lasts up to 45 days. So nearly 2.5 months. So there's no difference in the pathogen getting into your body in a vaccinated or unvaccinated person. You don't have your mouth and nose closed off when you're vaccinated. It's still the same. The main difference is adaptive immune system response in the vaccinated person that has the ability to clear the pathogen in less than a week or two, compared to the adaptive immune response of an unvaccinated person, an anti-vaxxer, that takes over a month and a half to clear. Now, I certainly know which one I'd rather pick for my loved ones, but what about you? Which one will you pick for your loved ones? Around 10 days to clear a pathogen or around 45 days to clear a pathogen? How long and how severe an illness and a sickness do you want it to be? How long and how severe do you want your children being in a disease that's preventable?